There we go. So we were going through centroids a bit, so let's keep going with that. So centroid is a center. The formula to find a centroid is you use basically a weighted average. So what you do is, if you want to find x bar, you sum up. You cut the object into parts, areas. You find the x bar distances to each of the centroids of the area. You add those all up and divide by the total area. That's how that works. And that's how you find a centroid. The centroid is named after the direction you measure it in. So x bar is measured in the x direction from the y-axis, actually. Okay. So we went through this one example here. We just kind of sketched this one up in class, where we went ahead and found x bar. What we did, we got the areas and we got the x and y bar distances for this shape, this notched rectangle here. And then we summed up the products of the areas times the offset distances. So 32 is the area of the large rectangle times 4, which is the distance to its centroid from the y-axis, plus 4, which is the area of the smaller rectangle, times 7, which is the distance from the y-axis to its x-centroid. The total area is 36, so we add the products together, divide by 36, we get 4.33. We do the same thing in the y direction. Same areas, different centroidal distances. 2 for the 32 centimeter squared area, 5 for the 4 centimeter square area. Add up the products, divide by 36, we get 2.33. So, we okay with that? That's basically how we find centroids. Okay. Now, an approach I like to take on these sometimes is to make tables, because they work, I can kind of keep my stuff straight. When I do that, I can be a little bit more organized about it. So quite often what I might do there would be to have an area, column for area, a column for x bar, and then a column for that little x bar times the area. So I might do something like that. And I would have part number, let's call this part number 1 here, and part number 2. So what I would do then would be to do something like that. 1 and 2, I'd have the areas 32 and 4, and these would be centimeters squared for the area. Then I would put the x bar in another column. So that would be what? That would be, for x bar, that would be 4 and 7. And then I would multiply everything together. So 32 times 4 would be 128. 4 times 7 would be 28. So then I would have a column to sum everything up. So the sum here would be 36, and the sum there would be 156. So x bar would be 156 inches cubed. No, inches squared. Yeah, it is inches cubed divided by 36 inches squared. And that would get me the same x bar. Okay. And it's not inches, I'm sorry, it's centimeters. All right, so that just helps me to organize the information. As I get into more and more complex shapes, that becomes more important for me to do. Okay, so that's how I would probably set something like that up. So if I could just remember how to set up the table, I could just fill it in and figure things out. All right, which leads us into the next one, which is a bit more complicated. So what I have for the next one there is a more complex problem. I'm on page 630 is where I am, so page 630. All right, so here we go. So I've got a table set up for you on this, and this is a fairly complex shape, so we're going to have to break it up into pieces. So what I have there is a triangle, right there, a right triangle. Then I'm going to have a rectangle. I'm on 630 is where I'm at, like that. I'm going to put another triangle over there on the end of the rectangle. So that'll look like that. And then I'm going to have a semicircular cutout. So that's what I'm going to do with that. Okay, I'm going to break it up into 4 pieces. Now I can go ahead and do that. Now notice that that semicircle cuts across both the rectangle and the triangle, but that's okay. I can just take it out as one semicircle. Okay, so I'm going to call those parts 1, 2, 3, and 4. And I go ahead and sketch them up, and I'm sketching in the dimensions from my reference axes, X and Y, to the centroids of those shapes. So there's Y and there's X. So I've got everything sketched up now. So parts 1, 2, 3, and 4. And I'm just going to work through those. I do want to have that sketch because, again, that'll tell me a little bit if I'm getting kind of off base, so to speak, if I'm misestimating or miscalculating something. Those sketches will help me to notice that if I'm making some sort of error. Okay. And also keep in mind, even though that semicircle crosses from the rectangle into the triangle, we don't have to do anything fancy with that. We just treat it like a semicircle. It all kind of comes out in the wash, okay? All right, so there you go. So let's go ahead and start to run some numbers here. Part 1 there, that is the triangle to the left. Okay, its area is 1/2 base times height. The base is 12, the height is 24. So the area is 144. 1/2, 12 times 24, right there. So 144. Yeah, I've got the units up above there. Yeah, that would be centimeters squared. So I put the units in the headings of the table. That way I don't need to write them into each entry. Okay, now what I've got here is I've got a triangle like that. And then I've got the axis that's running right through the middle of it. And actually, when I'm doing X and Y bar, okay, so I've got the axes. I guess I'll put those in black there, like that, and like that. So let's mark where the centroid is of the thing. It's right there. And this is 12, and that's 12, and that's 12. All right, now if I want to know where X bar is, what I'm going to do, I'm going to go to the third point of that right triangle because the centroid's a third of the distance from the right angle. So I'm going to go 1/3 of 12 that way. So this is minus 12 over 3. It's -4 in there. Okay. I know that writing's a little bit small. The area is 144. The X bar is minus 12 over 3. It's minus because it's to the left of the y-axis there. Okay. Okay, now y bar is a little bit trickier, but what's going on? I'm going up 12 for y bar. So I'm going to go up 12 to get to this right angle, to that edge. And then I know that the centroid is 1/3 of that height. So that'll be 24 over 3 down. So what I'm doing there is I'm going up 12 to get from the x-axis to the top edge. And then I'm coming back down by 1/3 of the total height, which is 24 over 3. So I'm coming up then with 4 for that. Okay. And so basically I got to come up with the area, which, you know, is a pretty straightforward thing to do. The challenging part of this is coming up with those distances. But once I have them, I just do the multiplication. So I'm going to take -4 times 144, and that's -576. And then I'm going to take 4 times 144, and that's 576, okay? So that gets me that filled in. So I got 144 for the area, -12/3 for x bar, 24/3 for y bar. I'm sorry, 12 minus 24/3 for y bar. And then 4 times 144 for both of them. I think I should have a negative in there. I think I dropped that. Yeah, I've got it. I didn't drop it. It's right there. Negative on the first one. Okay.
Why is it 12 minus 24/3?
Why is it 12 minus 24/3? So I'm going 12 up. Yeah. From the x-axis to the edge, and then I come an 8 back.
Like, we're just talking about.
So this is 12. It's dimensions right there. So 12 up to get from here to here. Yeah, a third of 24 back down. So the difference is what I want. So what I want in there is the difference between, it turns out to be 12 and 8. And that's that distance that I want. And that is right there. That's the distance I want. That's 4. 12 up, 8 back. Now there's other ways you could find that if you wanted, but that's how I found it. Yeah. X bar? The 3's from the formula. There's a centroid of a right triangle is a third of the base.
A third of the 12, it's 4 cents.
Right. Yeah, -4, because I go to the left.
-4.
Yeah.
Did I bust something out?
No. Okay, never mind. No, I see it now.
Right. Anybody else? We good?
Yeah.
Isn't the centroid of something 2/3 from one corner and 1/3 from the other?
It's 2/3 from the what I call the vertex, the acute angle, and it's 1/3 from the right angle.
So is it 2/3 of 24 is 16?
16 up from the tip here.
So shouldn't it be 8 down from the other side?
It is 8 down.
Yeah, 3 down from the top.
4 up, 8 down.
Oh, but it's 4 off the y. Okay, all right. Weird. Yes.
You could take 16 from the tip here, minus the 12. Because that's Other questions? Go ahead. All right, so we got the next one. We've got this semicircle. Now, what we don't have that much information for a semicircle, but we got it for a quarter circle on your formula sheet. It's 4r/3 pi from the right angle for a quarter circle to the either dimension to the centroid. So 4 times the radius divided by 3 pi. That's the formula. And I know that's a little hard to read. So it's 4r/3 pi. And it's the same dimension right there. They're the same thing. Okay? 4r/3 pi. Now, if you put 2 quarter circles together, what you get is a semicircle. So both of those centroids will be that height. So the combined centroid will be right on that midpoint line at that height. So this dimension will be 4r/3 pi for a semicircle. The centroid will be right in the middle, though, right in the middle of the semicircle. Okay? So that's a cutout, okay? It's been removed from that shape. So it's a negative area, -1/2 pi r squared. So -1/2 times pi times 9 squared. And that's -127. So that's the area of the semicircle. All right, now x bar is just dimensioned. It's right in the middle of the semicircle. It's 6. It's just given right there. So it's 6 centimeters. Yeah, it's a little confusing there, but yeah, it's split kind of, but it's the radius is 9. Okay, now we're doing the same sort of thing we did with the triangle. We're going to go up 12 from the x-axis to the edge, and then come back 4 times the radius of 9 divided by 3 pi, and that's 8.18. So that's the dimension from the x-axis up to that centroid. It's 8.18. That's in the y direction. Okay. All right, and then we got x bar times a, 6 times negative 127, and we got y bar 8.18 times negative 127. So you got to watch your signs on this stuff. So this is negative 1041, and this is negative 763. So be careful about signs on this stuff. That's a cutout, so those are negative values. Okay. Yeah, a question there.
Can you explain why it's negative 1/2?
It's negative 1/2 because it's cut out. We're removing the material. So, okay. And so it kind of, so that's the so that's a cutout. So the fact it's a cutout makes it a negative area. All right. Good with that one? All right. Okay, that big rectangle area is just 24 by 48. It's 1152. X bar is, we got 48. It's coming right off the y-axis, so half of that is 24. Y bar is right on the x-axis, so it just zeroes out.
And then we're later on going to subtract the area of the half circle we took from ourselves.
Yeah, we made it a negative. That'll make us subtract it.
Yeah, okay.
So, you know, I put the sign in how I calc it in the beginning. Then it all, you know, okay. Okay, so the X bar A entry is 27,648, and the Y bar A entry is 0 on account of that Y bar distance being 0. Okay, and the last one's the triangle. We're okay with that. Okay, the triangle then, 1/2, 18 times 12, so base of 18, height of 12, 1/2 times 18 times 12 is 108. That's the area. Now you do need to remember what I call the offsets to get the X and Y bar. That first offset there, you got to go 48, then you take 1/3 of 18. So it's 48 plus 18 over 3, which would be 6, so that's 54. Okay, because you got to go 48 from the y-axis just to get to the edge of the triangle. Okay. Now the triangle is also below the x-axis. It's in the negative y direction, so that's a negative distance. You're coming from the vertex, so to get to the centroid of the triangle from the vertex, it's negative 2/3 times 12, negative 8. All right, so we get 54 for the little x bar and negative 8 for the little y bar there. So then we just multiply the x and y bars times the area. We get 5832, and we get negative 8 times 108, and that's negative 864. So you can pick up negatives in two ways. One is if it's a negative area cutout, The other way is if you're to the left or down, that's a negative distance. Okay. All right with that? Okay. So now the table's filled in, you just need to sum up the area column and the X bar A column and the Y bar A column, and then just do the division and you'll get the centroid. I always like to check out, what I come up with based on those calcs, okay? Just to make sure it kind of makes sense, that it looks about right. Okay. So when I sum everything up, I get 1,277 for the total area. I get 32,141 for the X bar A, and I get negative 1329 for the Y bar A. I just divide everything, do the division. So take the 32,141, divide it by 1277, get 25.2, and then negative 1329 times 1277, I get negative 1.04. So that.
You need to add your X's and Y's.
I'm sorry now?
Do you need to add my X's and Y's?
No, there's no, you don't need to
No need to do that. Okay.
Yeah, it doesn't get you anything. And whenever I'm done with this, I always plot it up and kind of have a look at it, kind of hope that it makes sense. I'm looking at a centroid about over here somewhere. That seems about reasonable considering that cutout. We'll kind of pull that to the right, you might say. Looks about right. Okay. Questions on that? So that's a little bit more complex centroid problem there.
What does X bar represent?
It's if you have a plate of steel of uniform density, X bar and Y bar are the balance point for it. So if you hold it horizontally, you could balance it on the tip of a pencil, if everything was perfect and got just right.
It's like the broom trick on Facebook.
All right, yeah. Okay.
Hey, y'all fell for it.
No, I don't think I'm getting mad at me.
Okay. All right. So, okay, let's look at one other. We got a quick one, a 3D one. Let's look at that. It's on the next page, 634. Okay, so there's a sketch of where that centroid's at, the orange bit, okay? Right there, okay. All right, let's have a look at this. Let's say this bar is centered on the y-axis. I've got just a solid rectangular bar. Fancy word might be a rectangular prism there. I've got the density of A and B, two different materials. Density is the mass per unit volume. So let's figure out where the center of mass is. Okay, now the fact these have different densities makes that a little bit more involved than what we just did. We just have to have an extra step. So what we want to do is find the masses of each object. Find the volume first. They're just rectangular prisms, so you just multiply the dimensions together. 8 by 2 by 4 for the A, 3 by 2 by 4 for B. Then multiply those by the two different densities and you get masses. So this just involves an extra step. Okay. So 64 centimeters cubed and 256 grams for A, and 24 centimeters cubed and 43.2 grams for B. Okay. Now, once you've got the masses, then you just use the masses and do the same sort of center of gravity trick. That's the same sort of thing like we did with the centroid. Just multiply them by their offsets from the two axes, x and y, and z. Actually, three axes, but x is pretty straightforward because the bar is centered on x, so x bar is just 0. Okay. So I think I put a table on there for you. I did. Just fill it in, okay? So 256 and 43.2, get x bar and y bar. Looks like I did y bar first there. So half, hang on there, what am I doing? I'm going half of 8. That doesn't look like y bar to me. It looks more like x bar. Yeah, okay. I pulled the wrong table there. That's x bar and then x bar m. There we go. So half of the 8 would get you 4. So that's the distance from the z-axis. And oh, that is y bar because I'm not doing a two-dimensional problem. It's 3D. I'm sorry, messing up your table. It is in the y direction because it's a 3D problem. X is coming out of the page. Okay, there you go. So 256, we're going to go 4 over to get to the centroid. Then we're going to go 8 plus half of 3. That'll get me 10.5. So 8 plus 1.5. No, it'll get me 9.5. There we go. 9.5. There we go. Okay. Okay. So then I take the 43.2 times 9.5. I get 410.4. Add this stuff together. I get 1434.4. Total mass is 299.2. Divide everything out, and I get 4.79. Okay. So you can do the same sort of thing there with that type of problem. Okay.
So if you wanted to do the 3D center, you'd do Z, Y, and then X.
Right. Although X is right at 0 because you're given, initially when I wrote that down, I told you that the thing's centered on the x-axis or y-axis.
Oh, yeah, no, I didn't notice that. Then, yeah, it doesn't matter.
So X bar is 0. What's Z bar for that? Do you need to do any calcs for that? Z bar.
You should just be halfway up Z.
Yeah, right.
They both have the same height.
Yeah, they're both same height. They're not the same density, but they both got uniform density. So the centroid for both pieces is 2. So it's 2. Yeah. You could calculate it, but there's no reason to do it. You don't have to.
What's centered where?
Okay, what we're doing here, we're going up. We're just talking about Z bar. We want to find that. See, that centroid for A would be half of 4, would be 2 centimeters up.
Are you saying that
The
we're
whole shape
finding
is-
the centroid of the A and B because they're different lengths,
Yeah.
but because they're the same in the Z dimension in every way, right? They're the same height. Then you can just say half as tall for the Z for
Yeah.
both of them. So then the center of A and B in the Z direction is just 2.
They're both 2, so the total's
You
2.
can like look at it instead of doing
Yeah.
the math. You can do the math, but you'd end up with 2.
Yeah, right. Okay. So there's the math, that it comes out to 2. You know, it's not a big deal.
So, would we have to run calculations for C bar? Would you want us, we could just easily say that it is?
Like if you had a problem like that,
Yeah.
I would just say it's 2 because, you know, A and B are same height,
Yeah.
with uniform density, so it's 2. You know, you can just write out, just tell me how you're getting to your answer, I guess.
A was taller than.
It would change, yeah, change, right. Right. All right, so that's a bit on centers of mass and centers of area. Center of area is called a centroid. So, take a break here, I think. All right with that.